Hello students, it will be very helpful to you if you go to the playlist. From playlist you can select the chapter wise total lecture, and lecture will available at Bengali version and English version. You can select from these two languages. Here we will discuss about the motion of the connected bodies. Here the four types are shown here. One, these two types, the mass directly contact to each other, and here the mass are connected with this wire. Here the mass are connected with direct to each other. Here the mass are connected a string. This string is not expansible and this string is massless, and the plane where the mass are placed is a frictionless. The plane where the mass is placed is a frictionless plane. You have to discuss all this problem, the total acceleration of the system. Here the total acceleration of the system, and here also the total acceleration of the system, and here the total acceleration of the system. And if you apply the force F, then the mass M2 exerted force on the M1, that means a reaction force, you can also called R1, and this will be the action force, and reaction force E is equal and opposite. You have to calculate here what is the magnitude of A and what is the magnitude of R. And here the two action and reaction force, one is here the R1 and here the R2. Here the R2. This force is equal and opposite. This force is equal and opposite. The R1 force is exerted by mass M2 on M1, and R2 force reaction force is exerted by mass M3 on M2 and M2. Here we have to calculate what is the magnitude of A and what is the magnitude of R1 and what is the magnitude of R2. This is the three types, and here you can see that if you apply force here, the tension this type, and here is T. The tension of the wire, and here will be calculate a for T1. Will be a T1. This is a T2. There will be a T2. You have to calculate here what is the magnitude of A, what is the magnitude of T1, and what is the magnitude of T2. Here also you have to calculate what is the magnitude of A and what is the magnitude of T. It is very easy using the free body equation of motion. First we have calculate this, what is the acceleration of the system. Here we use two fundamental equation: total resultant force, resultant must be mass into total mass into acceleration. Here the total resultant force is F of the total system equals to mass of the system equals to M1 plus M2, and here the acceleration is A. That means A equals to F by M1 plus M2. This is the acceleration of this system. Here we have to free body equation, that is we have to calculate only the mass of M2. Here you consider the mass of M2. Here the force on the mass M2 is R1, and acceleration of the mass is a. That means this R1 force acted on M1, not on M2, because the action and reaction force does not acted on one system. This is the different system. That's why the force on the mass M2 only R1 and R1. This R1 is acted on M1. That's why you can get that the force on M2 mass is R1, the acceleration of the mass A, because the total system is accelerated by A. For this mass M2, you can also write that resultant force R1 equals to M into A1. Here mass is M2, that's why the resultant force R1 is equal to mass into acceleration. Here mass is M2, that's why mass M2 equal to into A. Here you can put the magnitude of A. Here M2 divided by here the magnitude of A means M1 plus M2 multiplied by F. That is the value of R1. Here you have to calculate the acceleration of a system. Here the acceleration of system, you have to calculate the reaction force R1 exerted by M1 M2 on M1. Here the R1 is M2 divided by M1 plus M2 into F. This is the type 1 is completed. Then you have to calculate the type 2 problems. Here the total force is M on the system. That's why you can get total force equals to total mass M1, M2 and M3. That means M1 plus M2 plus M3. And here the acceleration of the system is A. That means A. Here is acceleration is A. That means A equals to F divided by M1 plus M2 plus M3. This is the acceleration of the system 2. Acceleration of the system 2. And here you have to calculate what is R1. R1 means force exerted by M2 on M1, and R2 means force exerted by M3 on mass M2. This is the you have to draw the free body motion of M1 and M2 and M3. Here the M2 mass M2. Here two force is acted. One is R2. Direction of R2 along this direction. This R2 along this direction on mass M2, and R1 along this direction. R1 along this direction. And total system go through with acceleration of A. Acceleration of A. Here the total system go through this direction. That's why R1 greater than R2. That means resultant force R1 minus R2 equals to total mass means M2 into acceleration is MA. Equation number 2. Here the equation number 1. Acceleration of the system is equation number 1. Here the equation of M2 mass is R1 minus R2 equal to M2 into A. Here draw the free body motion of mass M3. Here draw the mass M3. Here mass M3. Only one force is acted on mass 3, that is R2. The total system go through by acceleration A. That means R2 equals to M3 into A. This is the M3 into A. Here A is the magnitude F by M1 plus M2 plus M3. That means R2 equals to M3 divided by m1 plus m2 plus m3 into f. That is the value of r2. That is the value of r2. And here you put the value of r2 here, that you can automatically calculate the value of r1. That means here you have to calculate here. That means this is the problem. You have to calculate r1. Here the value of r2 means m3 into a equals to m2 into a. That means r1 equals to m2 into a plus m3 into a. That means m2 plus m3 into a. Then you have put the value of a. Value of a means f divided by m2 plus m3. m2 here is m1 plus m2 plus m3. This is the total force exerted by m3 on m2. Here is r2, m3 by m1 plus m2 plus m3 into f. Here is r1 is equal to m2 plus m3 divided by m1 plus m2 plus m3 into f. And what is the acceleration? Acceleration is f by m1 plus m2 plus m3. This is the bodies connected to each other by contact. Then you have to calculate the connected bodies with the string. Here the calculation will be same. Here the total system accelerated by a. That means total force is F equals to total mass. Total mass is m1 plus m2 into acceleration. That is mean acceleration is equal to m1 plus f divided by m1 plus m2. The same as calculated earlier with connected to each other body. Here you have to calculate t. For this t, you have draw the mass m1. Only t is acted on mass m1 because the opposite here the plane is frictionless. That's why there is no force along this direction. That means total system accelerated by a. For this mass m1, you can write that total force T equals to mass into acceleration. Here T means m1 into a means f by m1 plus m2. That means m1 divided by m1 plus m2 into f. Here the equation of T. That means what is a? Means f divided by m1 plus m2. And what is t? T means m1 divided by m1 plus m2 into f. This is the what is a and what is at. The tension of the wire and acceleration of the system. You can easily calculate this using the equation total force equal to mass into acceleration. Total force equal to mass into acceleration. Here also you calculate easily the acceleration of the system and tension of this string and tension of this string. Total system is acceleration along this direction is a. That means total force is applied here F. That means total force F equals to total mass. That means m1 plus m2 plus m3 into acceleration a. That means acceleration equals to F divided by m1 plus m2 plus m3. This is the acceleration of this system number 4. And you have to calculate T1 and I have to calculate T2. For T1, you have to draw the free body motion of M1. Here is M1. M1 is only one force is acted on it, mass M1. Here the only T1 force is acted on this mass M1 and this mass is accelerated through A. That means total force T1 equals to M1 into A. You can put the value of A, that will be M1 divided by M1 plus M2 plus M3 into F. This is the value of T1. That means you can calculate the A. What is the value of A? A equal to F, total M1 plus M2 plus M3. Here what is the value of T? T equals to, you have calculate M1 भाग divided by M1 plus M2 plus M3 into F. And you have to calculate T2. For T2, you have to draw another picture. For this, you have to go the mass M2. Here the mass M2. Here two force is acted on it. One is here, this direction is T2 and this direction is T1. For this, here the tension along this direction is T1 and along this direction is T2. Here along this direction T1 and along this direction is T2. And total system of M2 is accelerated through this direction. That means T2 greater than T1. The total resultant force equal to T2 minus T1 equals to total mass of this body is M2 and acceleration of M. That means T2 equals to T1 plus M2 into A. You have calculated earlier the value of T1. T1 means M1 into A plus M2 plus A. That means M1 plus M2 divided by the M2 into A. You can put the value of A. Value of A is F by M1 plus M2 plus M3 into F. This is the tension 2. And what is the tension T2? T2 means M1 plus M2 divided by M1 plus M2 plus M3 into F. This is the problem related to the motion of a connected bodies. That means to connected directly contact to each other and also the string connected by the string. You have to calculate the acceleration of this system and force exerted by one mass to the another mass, and also for the connected body with the string, you also calculate the tension of this wire or string. This is the problem related to this connected body. You can also solve the problem related to this. For this you have to apply this formula, this theory. We describe the problem on a motion of a connected bodies. Here is one problem, here is another problem. Here is two mass, one is 10 kg and one is 15 kg. If you applied force 500 newtons, what will be tension of this wire? And here this force is exchanged. That means if you have applied this force on the mass of 15 kg, then what will be tension of this wire? And here the two bodies 1 kg and 2 kgs. You have applied the force on 1 kg. Here you have to calculate what is the contact force. That means here R1 and this will be a R1. You have to calculate R1. and acceleration of this system. Here the acceleration of the system and contact force of these bodies. You have to calculate contact force of bodies. Here two different cases are shown here. One, if this force is applied on a body of 10 kg, and what will be the tension? And force, if you force apply on 15 kg, what will be the effect of the tension? You can easily calculate this problem. You have earlier learned the theory. That means you have to calculate first the acceleration of the system. For this acceleration of system, here the acceleration along this direction, the acceleration will be along this direction because the force is acted along this line. That means total force equals to total mass 10 plus 15 into total acceleration. Here the force is equals to 500. That means here is 25 into A. That means A equals to 500 divided by 50. That means 20 meter per second square. This is the acceleration of this system. Then you have to calculate the tension of this wire. For this you have to draw another picture. That means only mass of 15 kg. This system goes through this acceleration A. The force acted on this mass 15 kg is T. That means total force acted on this body is T. Here total mass is 15 and acceleration is A. You have earlier calculated the acceleration of this body, total system is 20. That means this mass also have an acceleration of 15 meter per second square. That's why this will be 15 multiplied by 20. That means 300 newtons. Then what is the tension of this wire? Is 300 newton. Here you have applied the equation total resultant force equal to mass into acceleration. Here resultant force is 500. That means total mass in 25 into acceleration will be 20 meter per second square. And here you have to draw the free body of mass m 15 kg. That means here is 15 kg mass. Total force on this body is T and acceleration will be same A. That means total force T equal to mass into acceleration. That means 300 newton. If this force is applied on this 15 kg mass, what will be tension is here you have to calculate. Here the acceleration must be same because total mass 10 plus 15 into this acceleration will be along this direction. Acceleration equal to total force means 500 newtons. That will be A equals to 500 newtons divided by 25. That will be the same 20 meter per second square. Here what will be the tension on this wire or string? For this you have to draw this free body diagram. That is means 10 kg. The force acted on this body is T dash. Acceleration of this body is A. That means T dash will be mass of this body multiplied by acceleration. Here acceleration is 20. That means 200 newtons. You have easily calculated the two different cases of a problem. Here the tension is 200 newtons. Here is tension is 300 newtons. But both cases the acceleration is same because the tension is because the mass is lower than 15 kg. That's why here tension is greater and here is tension is less. Here you have to calculate the same problem, but here the bodies are connected to each other. Here the bodies are connected to each other. For the first cases, the total force is 3 Newton. 3 total force, that means total force equal to mass m1 plus m2 into acceleration. This acceleration will be a, that means total force is 3 Newton and total mass is 1 plus 2 into acceleration. That means acceleration will be 3 divided by 3, that means 1 meter per second square. You have to calculate the value of R1, that means contact force, the contact force between these two masses. For this you have to draw the free body only mass m2, that means 2 kg. The 2 kg mass, the force acted on this mass 2 kg is R1. The acceleration of this mass is A. That means you have used the total resultant force equal to mass into acceleration. That means mass is 2 kg and acceleration is earlier calculated. That means 1. That means 2 Newton. Here the contact force is 2 Newton. Here the contact force is 2 Newton. That means what is the value of A? Here value of A is 1 meter per second square. Here R1 is 2 Newton. But here the force is applied on the mass 2 kg. Here the force is applied on mass 2 kg. What will be the effect on the contact force? Here the total acceleration must be same, because total force 3 equals to total mass 1 plus 2 into acceleration. That means acceleration will be 3 by 3 divided equals to 1 meter per second square. That means acceleration is same, but here the contact force, that means here say R2, that means both the same and opposite. Here for this you have to draw the mass of 1 kg, because 1 kg is exerted by force R2 and this mass is accelerated along the distance with A. Then what will be the acceleration? R2 equals to mass into acceleration, that means 1 meter per second square, that means 1 Newton. Here the contact force is reduced by 1 Newton. Here is 1 Newton and here is 2 Newton. That means A equals to 1 meter per second square and R2 equals to 1 Newton. This is the problem related to the motion of the connected bodies.